I'd like to request all of you to please give him a big round of applause as I invite him onto the stage for the keynote, Mr. Krishnan Shrinivasan, Managing Director, Lam Research.
So first of all, I'd like to thank the IESA for giving us the opportunity to talk a little bit here. I know it's a little bit difficult because you've just probably had a big lunch, and I'll try and make my speech as short as possible. I'm here representing Lam Research. I'm responsible for Lam Research's India operation. My name is Shrinivasan. And what I hope to present to you today is more in the nature of a continuum from this morning's discussions. And if I were to try and extend the categorization of Mr. Rajamanikyam this morning, if the chip people were the poor people and the software people are the rich cousins, I don't know where that leaves us in the semiconductor capital equipment industry, but maybe orphan cousins might be more like it. So very quickly, what I'd like to talk about today is intelligent electronics and automation in the perspective of a semiconductor capital equipment company. And I think we are affected by this in two different ways. First of all, we actually enable, at a very fundamental level, advances in automation and intelligent electronics. If you were to accept the fact that semiconductor devices and integrated circuits are at the base of the intelligent electronics revolution, then our equipment basically enables that revolution and that technology. And also, on the other end, our equipment itself is a beneficiary of intelligent electronics and automation. And I'll try and kind of illustrate that point with a few examples here. Just a few words about Lam. We're a global leader in wafer fabrication equipment. We are today the world's second largest manufacturer of semiconductor capital equipment. We have worldwide presence, including that in India. And approximately 1,000 people work for us from India in a variety of different areas, including software engineering, hardware engineering, and in providing support for our manufacturing operations. Last year, we were about $10.9 billion in annual revenue. And we have a history of plowing back a significant fraction of our revenue into R&D, so approximately $1.2 billion in R&D expenditures last year. Our main product lines basically are in deposition, etch and strip, and wafer cleaning. Now, you can look at it this way. All the new products that we develop in these particular areas go into some of our leading-edge fabs worldwide that are making leading-edge devices, both memory and in logic. But we also have a significant operation and service and support that's going to be very critical to this new emerging IoT revolution and Industry 4.0. Because some of our older products that were used for leading-edge products a while ago are now getting an extended lease on life in the manufacture of some of these sensors and devices that are used in the IoT revolution. Traditionally, the semiconductor industry and the capital equipment industry were driven by single vectors of growth. And we typically had the PC, the mobile revolution. We've always had automotive electronics be a driver of growth in our industry. But that was primarily aimed at sensors and microcontrollers for the operation of the car. And increasingly, we see the automotive applications for semiconductor devices extend into autonomous, semi-autonomous driving, advanced safety, and so on and so forth. But increasingly, we're beginning to see these other drivers of growth in the industry. So what used to be a single vector industry is now beginning to be supported by multiple vectors of growth. We are, of course, all interested in the IoT and all the other applications that sit on top of the universe here. But the important thing to understand is that IoT by itself is not what drives the industry. It's all the stuff that's necessary to support IoT in the network, in the data centers, and with all the applications in machine learning sitting on top of that. Our estimates, and this graph, by the way, is our perspective, and there are many other perspectives on the information contained within this graph. But as we move from networked electronics to networked industries and on to networked society, we estimate that by 2020, we will have about 30 billion connected devices. And that continues to exponentially increase, and by the time we reach 2025, we'll be looking at about 75 billion connected devices, which is a huge market opportunity for people who are making these chips, for people like us that make equipment, and also for people who are writing applications on top of it. Now, the interesting thing to note here is that a majority of this demand is actually being filled by older equipment from our perspective. And this goes back to the comment I made a few minutes ago that IoT is driving an extended lease of life for our equipment. Our customers are beginning to repurpose their leading edge equipment for IoT as things go forward. And so we'll talk a little bit about that and how the equipment industry is dealing with that revolution. Very broadly speaking, the way we look at the world is shown in this slide. So we have on the edge things with sensors, and that could be related to energy, industry, healthcare, transportation, any application that you would think of. And on the right-hand side would be the leading edge applications, data centers, and analytics. So you can roughly divide the world this way. The leading edge devices that we make, or that our customers make, are used for data center applications. And the greater than 28 nanometer universe is feeding demand on the left-hand side of this chart. And so that's the opportunity that people like us have to try and take equipment that comes off the leading edge and make it work towards the back end of the chain. So here are some examples. You would see adjacent markets, pretty much things that are at the edge. These are sensors, image sensing, power management, or photonics applications on the edge of the network. And of course, the traditional CMOS markets in memory, logic, and in flash would be working on the data center end of the market. And we have taken our entire suite of products from etch, dep, and clean and have begun to successfully apply them in both areas. And we have shown an ability to, for example, take equipment in the leading edge markets and renovate them and innovate with them to make them applicable to the left-hand side of this chart. So, for example, here are a couple of our products. We are known as an etch and a deposition company. We're a plasma etch company and a thin film deposition company. And these are what were leading edge products about 3 or 4 technology nodes ago, now that are being updated with things like improved repeatability, defect reduction, throughput improvement, as well as kind of reduction in the abatement or greenhouse gases. So we've been putting these new innovations on these machines and repurposing them for the sensors and the IoT world. This is probably not the world's most attractive Industry 4.0 chart. There were some other better ones shown this morning. But I think as we walk forward, one of the things we look at is Industry 4.0 leading to computerization and digitalization of the entire industry, all the processes. And I want to switch at this point from what we are doing to enable Industry 4.0 to a conversation about how Industry 4.0 is going to enable us, and how are we going to improve our machine technology with this revolution in mind. So, a number of different things are happening. We are using big data ourselves, deep learning algorithms, and all the specialized processors that have now become available to us to innovate within our own machines, to innovate within the control systems of our own machines, and improve the rate at which we can provide services and benefits to our customers. Just to give you an example, in the automotive world, the Industry 4.0 represents a transition from a backward-looking control systems and sensors universe to a forward-looking predictive environment, where we can look at where we are going and try to change behavior depending on what we are seeing. So that's how things work in the automotive market, and we have an analogous situation with our equipment, where in the old days, the traditional sensors and process control were always looking backwards. We're always trying to fix problems that we had encountered in the past. And as we move forward in this universe, we have now a new phrase we call equipment intelligence that's being applied to our equipment in a way that we can look forward to improve wafer-to-wafer uniformity, load-to-load, and cassette-to-cassette, as well as chamber-to-chamber matching can be done in a predictive manner using the sensors and control technologies that we can embed within these machines. So this is actually a big revolution for us in the industry itself, and we hope to take advantage of the whole Industry 4.0 paradigm in making our machines more valuable to our own customers. Things that we are building into our machines include things like self-monitoring and self-tuning, the ability to kind of tune yourself, self-identification, so configurations of our machines can be identified through smart parts, and the machine can automatically configure itself for the parts that are used to assemble it. Predictive maintenance is a huge application for us. Some of these machines cost a lot of money, and they are probably not very useful if they're being maintained to our customers. So therefore, having more predictability around its maintenance schedules and downtime is something that we're looking forward for. Setup automation, setting up the machines, automating the setup of these machines, and calibrating them are also things that we can do through some of the newer artificial intelligence and machine learning technologies. So these smart tool capabilities, we think, are going to be accelerators for us in our fabs, and in turn, hopefully, deliver better results for our customers. So in summary, what I'd like to do is talk a little bit about kind of all the different elements coming together in the Industry 4.0 environment. What we think we're going to get from this is larger process windows, lower costs for our customers, higher yield, through the application of these various elements, data organization, so our ability to collect information from our products at a very high speed, store them, the ability to monitor the data and analyze them at the right time for the right purpose. We are doing advanced productivity solutions, so we are building an ecosystem of products and services that are allowing us to drive overall equipment efficiency, and also virtual processing, so computational etch and virtual fabrication technologies allowing for faster process development. That's an important advance for us. We're building all of this on top of a big data and machine learning platform with leading edge automation, sensors, and process control. So in summary, I just want to go back and restate the original purpose of this presentation, which is that while semiconductor equipment companies like Lam are at the leading edge of providing solutions by which our customers can develop processors and memory necessary, as well as sensors necessary for the Industry 4.0 revolution, we are also benefiting on the back end from these revolutions, and thereby kind of creating a virtuous cycle by which improvements in our machine result in improvements for our customer products, which feed back to us. So I once again want to thank you all for the attention you've paid. I'd be very happy to take any questions at this point. And go from there. Yeah.
You can listen, or you can
Yeah,
translate it. Okay, got
you're
it.
loud now.
So in one conference, I heard that the chip per se for IoT solutions seems to be so small that probably if you look at the existing capacity, it can be manufactured in a couple of shifts. So is IoT going to keep the semiconductor fabs loaded enough? Or do you see a trend where much of work is going to move towards software and not so much towards VLSI design per se?
I'm actually not much of an expert on how software works, but I think the profusion of devices, the profusion of technologies, and I think we talked about some of that this morning, about trying to replicate the human senses, right? And the number of devices, the sheer number of devices, we talked about at least 75 billion devices in the next 7 or 8 years, will keep many, many fabs fully occupied. We think that actually a number of our customers are repurposing older 200 millimeter equipment to build sensors and other devices for the IoT world, whether it's power management, image sensing, MEMS, and so on and so forth. So there's a fair number of applications for which I think fabs will be kept continuously running. And we will continue to repurpose our older machines for that. But you have to remember that the IoT world is just one edge of the spectrum. There are other things in between where I think newer applications will create newer demand for silicon at that point. I don't know if I answered your question. Okay, thank you very much for your time. Thank you for having me.
Ladies and gentlemen, please give him a big round of applause once again for that keynote, Krishnan Shrinivasan. I'd like to request Mr. Rahul Arya, Treasurer, IESA, and Vice President, Sales, APAC and Europe Region, E-Infochips Limited, to present a small token of our appreciation to Mr. Krishnan Shrinivasan.
Thank you. Yeah. But very pertinent, yeah. That's right. The gifts keep on coming.
Thank you very much indeed.